Hey people, it's Larry here. Figured I'd shoot one video of this system before I seal it all up with the sand up here and tidy up all the wires. This is a very redneck engineered aquaponics heating system that not only heats the greenhouse that I'm converting the garage into, but also heats the water for the fish tanks. As you can tell by looking at this thing, this is all custom built by a cousin of mine. What it actually started out as, if you look at this over here, this is one of those 18-inch by 10-inch barrel stoves. You see them advertised on Amazon all the time as a military tent stove. You know, they're not even close to that. They're actually just a little wood burning stove, and I've modified mine. I had to take the door off of it, and I added this little cane bolt here to latch my pellet and oil burning insert in place. But what this actually is, I mean, like I said, it was all custom welded up by my cousin. It's just a burn pot, 4 inches by 6 inches. As you can see right here, the oil actually comes in. There's where our air comes in. It actually comes down this tube, which is connected to these two computer blowers. There's actually two of them there. It's kind of hard to see. They're stacked on top of each other in a little custom, manifold made out of wood. And there's foam on this side of it, so it seals around that little half-inch pipe. And it comes in there and makes an immediate left turn, blows downward, and so it's constantly feeding air to the fire. If you look down in there, you can't really see it too well. It's right under the oil drip line. What there is a 1-inch wood boring drill bit that is used as an auger, and it comes through that bottom pipe over to this little area right here, which is a hopper receiver. And as you can see, there's wood pellets in it right now, and that is actually connected back here to a real wood pellet auger motor, which is kind of an underpowered one. It's only 1 RPM. I need something probably at least 2 RPMs because it just feeds pellets entirely too slow. But as you can see, that goes into the stove, and the way this stove is actually set up, there's a copper tube. It's 1/2-inch soft copper tubing, about 6 turns around that stove. And as you can see over here, there's a blue barrel. It's full of antifreeze and water. Comes through here, through the copper coil, gets preheated by the fire inside. And it comes out over here up into this piece, which is, the chimney goes up through it. That's an 8-inch heat exchanger. So there's a 3-inch chimney pipe in the middle, and it's 8-inch, 1/8 inch steel pipe welded together. So it's a water jacket around the chimney, and it captures even more heat. And you want to talk about some serious redneck engineering? Yes, I built all of my own custom controls for the thing. I shouldn't say I built them. I mean, I bought the parts and assembled it. But the way it works is up on top here. There's a thermostat, and unfortunately it's always in Celsius. There is no Fahrenheit setting for it. That kicks in at about 95 to 100 degrees Celsius, which is about, I'm no good with math off the top of my head. It's in the 200 degree Fahrenheit range, 200 to 205 degree. There's a temperature sensor coming off of that right here. It monitors the stove or the chimney pipe temperature. Once it reaches that 100 degree mark in Celsius, it shuts off the oil and the pellets, the auger, and the valve that's on the oil. and turns on that fan back there, which cools the chimney down, you know, as the oil is, or the fuel is shut off. And once it drops down to about 95 Celsius, it kicks back on again. There are some safety measures implemented here. Well, number one is this one on top. This is a low temperature sensor. If the chimney pipe is less than 120 degrees Fahrenheit, it kills the power to the stove. It won't run. It requires manual reset. I'll show you how to do that in a second here. Back here is an Aquastat. That's an upper limit safety measure. If the stove or the chimney pipe gets over 250 degrees, 240 to 250, it also kills the power and requires a manual reset. This little circuit back here is a cycle timer and a little voltage regulator that I had to add on to it for my hopper agitator, which, as you can see, there's the hopper. It's really funny. It's small. That is an electric screwdriver in there. Like I said, this is redneck engineering with a little wiggle wire on it. Probably can't see that too well down in there. What that does is every time the cycle timer kicks on, for about 5 seconds it runs that every minute, and it stops the pellets from creating a bridge and jamming up in the hopper. So those are pretty much the controls. What I'll do here is I'll show you how you actually light the thing, and it's really not a whole lot to it. As you can see down here, there's our burn pot. I'm just going to add some pellets to it and make a mess while I'm at it, because I can't seem to watch what I'm doing and run the camera at the same time. But here, just need to get those scooted back into place. That's all it takes to get started. About a half a cup of wood pellets. And I'm going to run over here real quick and grab me some lighter fluid. Charcoal starter. Yes, it's a messy garage. And I just, put a little in there and soak everything else. Not a whole lot. It doesn't take really a whole lot. And here we go. I'm going to have to maybe put the camera down. I'm not sure. See how well I am at working one-handed around here. And for those that are actually wondering how this actually heats the water, inside of that barrel is a pond pump it's actually got a capability of 350 some gallons per hour. But this faucet or valve down here, I actually have to choke the water flow down, because to get the greatest heat transfer, that water has to stay in contact with the heat source for a good amount of time. So that, what I did right there, that cranks it down to about one gallon per minute. And that's how, whoops, sorry about that. That's how we get this thing down to a usable temperature. And we light a cotton ball and drop it in there. Now, to actually jump start the stove, our low temperature bypass, I have to use an alligator clip here to jump it. And when I turn that on, as you can see, that creates a wicked flame. So I'm going to turn that off really quick. That was the air supply for the stove. I'll turn that off, and I'm going to put the inside of the stove here real quick. Since it's burning nice and well. Might be able to see the rest of it after I clear it, after I get it put back in here. Get this stupid cinder block out of my way. And turn our air back on. You can probably hear that rumbling. That stove is actually just pulling air in this little hole in the bottom, and that's where that rumbling is coming from. But there you can see the actual auger motor and the two blower fans. Those are just 25 CFM 12 volt computer fans. I would have used something else if I could have found something else, but oddly enough, whenever I'm building something, I can never seem to find what I want, and I have to settle for what's available. Alright, so that's running. But as I was saying with this, there's a pump in the bottom. It pumps antifreeze and water up through this coil, up through the heat exchanger, out through the heat exchanger, out this little white CPVC pipe, back down in. The way it actually heats the water in this IBC tank, which is where the fish for the aquaponics system are going to be, also there's a pump down here, and this little sump goes up into this PVC pipe across the back into the top of this barrel. Now what that connects to inside there is a 25-foot section of corrugated stainless steel tubing, that stuff you see used on gas lines, because your fish tank water can't actually come in contact with that, you know, that antifreeze mix, so it transfers heat that way. So the object here is to warm up this barrel to about 140 degrees, and the fish tank water pumps through that stainless steel coil in there, back out on this side, and there, you know, returns back into the fish tank. Here we'll drop our hopper on top of this. So this hopper is rather small, and you're probably wondering how in the world this could possibly work. There's the drill or electric screwdriver running the agitator. That hopper is only 6 inches by 8 inches and about 10 inches tall. There's not a lot to it. But between that hopper being full of pellets and the oil that's coming in, a whole hopper will actually run for about 12 hours in this, and that's because of the low RPM motor back there and that thermostat up there constantly turning things on and off. Let's see what else. Things that I haven't implemented yet, which I will. I have parts inside, I just haven't installed them. Down here in this section where the pellets are, I need to put infrared LED and a photo transistor on there to tell when I'm out of pellets, so it will shut the stove down. On the water over here, the sumps, there's 2 of them. They're actually bottom connected. I need to put a temperature sensor on the side of one of those. There's the agitator again. So if the water reaches 77 degrees, it actually shuts down the stove as well. Underneath this IBC tank, just for a safety measure, there is a waterbed heater, and I have a separate thermostat for that. So if that water were to drop to 65 degrees, the thermostat will turn on the waterbed heater until I can get out here and start up the stove again. That doesn't happen very often. It has to get blistering cold, and this place is really well insulated. I mean, if you look here, I got fiberglass insulation, and then it goes around over to this side where I'm just started working on the reflective walls. That's a reflective bubble wrap insulation, so your heat actually reflects off your wall back into your room. The chimney pipe is about the only part of the stove that heats the room. I have some collars that go on there that give it more surface area to heat the room a little bit more. But the main bag here is using a thermal banking to heat the room. Once that water in that fish tank is up to about 77 degrees, water is 1 BTU per pound per hour. That'll keep the 12 by 12 foot greenhouse area nice and warm all night long, even without any fire in here. And eventually, well, I guess my thermostat isn't going to kick that on yet, because 79.2 degrees Celsius, we're a long ways from 100 yet. But that's it. And as you can see, I got this little jumper up here. This is my little safety mechanism to stop other people from lighting my stove when I'm not here. Once that thermostat kicks the fan on, I know that it's safe. I can take that jumper wire off, and it'll run all day, or at least until I'm out of fuel. And when the temperature in the stove drops so far, it will actually, that will shut down everything, the whole shooting match. So let's see, just out of grins and giggles, where we're at right now. 317, 320, somewhere at the front of the stove. It's going to be 100 degrees hotter back here, so it's going to be about 420. The ideal temperature is to have this front about 450 degrees, 550 back there, and that gets this water in this heat exchanger going really good. It's 77 in there. I should have showed that before I started the fire. It was 67. So that shows you just how fast that actually warms up that water. So that's about it. Any questions, comments, whatever, go ahead and feel free to leave them down in the bottom here, and I'll post another video as soon as this system is all sealed up and tidied up and everything. So thanks a lot. Talk to you later. Bye.